Yes. So, Srikal students, let's study motion chapter 8, class 9, science. See that students, let's understand the difference between distance and displacement. Distance is represented by S or D, it has unit meter. Displacement is also represented by S, but a arrow on that. Okay, let's see why. Students, let's say there is a person which starts from A, which goes on some arbitrary path and reaches B, right? Now, as you can see, the direction of the person is not fixed. We can't tell the direction of the person. But yes, there is a value for the distance covered. He has covered some distance along this path. Along this path, he has covered distance. And that distance calculated in meter is simply the distance. It does not have any particular direction. Or we can say, yes, the person is going at this point in this direction, but as it reaches this point, its direction changes. So for the entire path, we cannot define any direction for this person from a distance between A to B. Okay, let us say this person covers this distance A to B in time t. Okay, so now we can say that the speed of the person is equal to total distance covered divided by the time t, right? That is equal to s by t. So from here we can understand distance as well as speed. If distance does not have direction, obviously speed also don't have any direction, but it has a value. Such quantities are known as scalar quantities. They these quantities, scalar quantities, have value known as their magnitude. Magnitude. For example, pressure is scalar, distance, density of a substance, mass by volume. These are all scalar quantities. Speed is also scalar quantity. But now our discussion comes with the direction. Let's say a person has gone from point A to B along this direction. He was at initial point A, he was at final point B, let's say in time t. Now, this distance covered in time t is known as displacement. Then displacement also can be measured in length in meter. Distance can also be measured in length meter. What is the difference? Difference is about direction. At every point, let's talk about 1, 2, or 3 points along the path of the person traveling from A to B, his direction is same. The direction is not changing. So we can say distance covered in a particular direction is known as the displacement. Displacement is symbolically written as S, but this arrow, now you can understand, represents what? It represents the direction. So we are having north, south, west, and east, four directions. If a person is traveling along these, we will say he is covering displacement. If he is even traveling along this, we will say he is traveling along northeast direction. Then if the person is traveling along this, we will say he is traveling along west south direction. This is the direction. Now students, Interesting thing about displacement. Let us say it is told that the person has traveled A to B in a straight line. He has traveled 3 meter. From B to C, he has traveled 4 meter along north direction. A to B is towards east direction. Now, it is asked after the complete travel, what is the displacement of the person? Now, students, his displacement from A to B is 3 meter. Displacement from B to C is 4 meter. But displacement from A to C is how much? How we will calculate this? We will use Pythagoras Pythagoras principle, Pythagoras theorem. What is Pythagoras theorem? We know that if it is a right angle triangle, h square is equal to base square plus perpendicular square. So students, now his this person's displacement will be the linear distance between his initial position A and final position C. At the end of the path, he is at C. At the starting of the path, he is at A. So AC can be easily calculated. AC would be equal to AB square, 3 square plus BC square, that is 4 square under root. So this is equal to 9 plus 16, 25 under root is 5. So I can say the displacement of the person from A to C is 5 meter. Am I right? More interesting thing, students. Let us say a person is going along a circular path. Let us say a person starts from point A, right? Now, let us say AB is the diameter of the circle. Now, let us say the person travels along the circular path in this direction, okay, along the circular path, and after some time he reaches B. He reaches B. Now, the radius of the circle is, let us say, 4 meter. Now, what is the displacement of the person from A to B? Can you tell, Karan Singh? The displacement of a person, as you have seen, is the linear distance between initial position and final position. So, what is the linear distance between initial position A and final position B? Simply connect A and B. When we connect A and B, then what is this? AB is the diameter of the circle. So his displacement from A to B will be 4 into 2, that is equal to 8 meter. Interesting thing, students, if he keeps traveling, let's say he does not stop at B, he keeps traveling and after some time he comes back to A. He comes back to A. Now, what is the distance traveled by the person? Distance traveled by the person is equal to circumference of the circle, that is 2 pi r, that is equal to 2 into 3.14 into r is 4 centimeter, approximately 4 approximately 24 centimeter, little more than 24 centimeter. But what is his displacement? I once again repeat, displacement is the linear distance between initial position and final position. Now the person has started from A, he has come back on A. May I ask Hargunpreet Singh that in this case, when He started from A, reached B, again keep traveling and he reaches again back. Can you tell what is the displacement, Hargun?
Yes, so 16.
No, you are wrong. The person has started from here and again he has ended here only. What is the distance between initial position and final position? 0. His displacement when he starts from one point of a circle and completes the circumference and comes back to the same point, this displacement is 0 meter. Let's take one more examples like this. Let's say a person has traveled 10 meter in this direction, then he has traveled 8 meters along north direction. Then let us say he has traveled 5 meter along west direction. Then he has traveled 4 meters along south direction. And from south direction, he has again traveled 5 meter towards the west direction, and from this again he has traveled south direction and reached the same point from where he started. Can you tell what is the displacement in this case? Yes, 0 meter. Correct. Displacement is 0 meter. What is the distance traveled by this person? Can anyone tell? What is the distance traveled? Please calculate. Yes, students. 10 plus 8, 18. 18 plus 5 plus 5, 10. How much? 18 plus 10, 28. 28 plus 5, 28 plus 5. How much? 33. 33 plus 4. This distance, 37 meter is the distance traveled by the person. Am I right? One more question. Let us say a person has gone like this. Okay. Let us say that this linear distance between these 2 points is 4 meter, and this total distance between A and B. This suppose this is a rope, this till A to B, and its distance is 25 meter. From A to B, if a person has traveled, what is the distance traveled? 25 meter. I am asking from A to B. A to B. What is the distance traveled? 25 meter. Hargun, can you tell what is the displacement from A to B?
4.
Correct. Displacement is 4 meter. Very good. Now we will do one more numerical. That numerical, okay, first we will find some differences between distance versus displacement. Number one, students always remember displacement divided by distance traveled is always less than or equal to 1. What does that mean? Let us say a person has gone from A to B. Now, what is the distance? Distance is this curved distance. But what is the displacement? Displacement is the linear distance between A and B. And this linear distance is the shortest distance. That's why students shortest distance is always smaller than the this distance curvilinear distance. So displacement of a person will always be less than distance. But if a person has traveled from A to B in a straight line, let us say this line length is 12 meter. May I ask you what is the distance traveled by the person from A to B? What is the displacement traveled by the person from A to B? Correct. In this case, the distance traveled and the displacement traveled is equal. That's why I told displacement is less than or equal to distance. Number two, if a body moves along straight line, distance would be equal to displacement. Number three, displacement of an object can be positive, it can be zero, it can be negative also. How? Let us say we are considering this distance as positive, right? So let us say a person has gone from point A towards the east. How much? From A, the person has gone towards the east, let's say 6 meter. From E, he travels back along the same line. How much meter? 8 meter. See, listen again. A to E, his distance traveled is 6 meter. From E to C, his distance traveled is 8 meter. What is the total distance traveled? Hargun, distance traveled is 8 meter,
14.
14 meter. What is the displacement? See, no, it's not 2 meter. Now right side we have taken positive. So the total displacement will be minus 2 meter, because if this direction is positive, automatically the opposite direction will be negative. Hence, I told that distance will always be positive or zero. Distance cannot be negative, but displacement has direction, right? So if a person is going like this, let's say it's positive. So if he goes in this direction, it will be considered negative. So displacement can be negative, zero, or it can be positive also. Last numerical, then we will finish this. He says, let us say a body moves in a circular path. This is the circular path of radius 20 centimeter. How much? 20 centimeter radius. If it completes 2.5 revolution, it completes 2.5 revolution along the circular path, right? Along circular path, that means along the circumference. Find the distance traveled and the displacement traveled. I give you 2 minutes, students. Please do it.
Into 0.
Okay, students are not able to do, don't worry. So, students, let us see. This is a circle. Okay, the person has traveled along the circular path. Let us say the person has started from point A. Okay, this is point A, right? After one revolution, he will again come back on A. After one revolution, after two revolution, he will again come back on A. After the again after half revolution, where he will be? He will be at B, diametrically opposite point, right? So at after completing 2.5 revolution, this person, this is the center of the circle, he will be at B. B point is diametrically opposite to A. Now easily you can tell what is the final displacement. This you can easily say. The correct, very good. This is 20 centimeter. Radius, his displacement will be 40 centimeters. Suppose it is asked, what is the displacement at the end of 3 revolution? 3 revolution means he will again come back on A. That will be 0 meter. Wow, very good, great. But what is the distance traveled? Distance traveled is, in one revolution, 2 pi r, right? In one revolution, 2 pi r. So in 2.5 revolution means 5 by 2 revolution. Am I right? So simply multiplied by 5 by 2. So, sorry, not displacement, but distance traveled will be 2 into 22 by 7 into r is 20 into 5 by 2. So it will be 11. So this will be equal to 25, 20 into 5 is 100. 100 and this is 2200 divided by 7, what, centimeter. So this will be equal to 314 centimeter. Okay, I wish you all the best, students. Hope you like the video. If you like the video, do subscribe it, consider subscribing it so that we can grow our channel and then we can give more knowledge to you and share with your friends. Thank you very much.